architecture, for example, developing procedures and understanding I/O, controlling actuators, and editing motions. My topics are as follows. First, I would like to speak of overall system structure, especially for electronics and software. And second is detailed specification. And next, I would like to explain development of environment, especially for what must be stored in your PC or DARwin. And next, I would like to speak of briefly software framework of DARwin, and especially for accessing devices, something like a gyro, how to access gyro and accelerometers to read some sensors value or controlling actuators. And next, I show you some examples. You must access with me and with him, so you can experience many exciting things with DARwin. Finally, I would like to speak about the software tool, which consists of basically of all kinds of software tools. As Kim mentioned before, DARwin system has two kinds of significant controller. One is main controller, we call it main controller. It is statistic, and second is sub-controller. Sub-controller CM730 is take charge of for communication management. So one is for protocol relay, and second is sensing interface. As you know, the host means main controller is not PC. Host access some kinds of many sensors like gyros and accelerometers, buttons or LED, and RS28M via the CM730. So CM730 is only have accumulated data from gyroscope and accelerometer, and otherwise, and it can post protocol information from PC to RS28M. Yeah, here is the overall system block diagram. As you know, there is a main disk, and there is a sub-controller here. The sub-controller CM730 accumulated simultaneously and real-timely the gyroscope accelerometers. And like this line means the dynamic cell line. It means the main controller can access by dynamic cell protocol, the tiny actuators, and through FSR board. Even if this headboard and interface board power has some kind of different device like a mic and LED is connected directly to CM730, it can only accumulate by CM730 and varying data by CM730 to main controller. Okay, next I'm going to speak of this specification. The first electronic specification for main controller PC. As you know, we are using PC. This CPU is an Atom from Intel. Its process performance of about 1.6 gigahertz. As you know, the length size of the PC is 1 gigabyte and 4 gigabyte is flash disk. It means that, you know, maybe SSD, solid state disk. It's very stable compared to the older one we use before the USB drive. There are so many problems, so we can change it to the 4 gigabyte flash disk. And as you know, it has the HDMI port for external video port and several audio port, and it has not only Ethernet port but also Wi-Fi and the USB port, and for external storage mini SD. And PC have officially support the Linux and the Windows XP and Windows 7, but in this time we adapt some kinds of Linux system called Ubuntu. Next is specification for CM730. We are
CM730 is a Robotis specific.
Yeah, actually, yeah, we made it ourselves. Yeah, we're using CPUs from the core is ARM, you know, maybe the ARM Cortex core. Actually, it's 5 times faster than we use the Artemis one. Yeah, that means frequency about 72 megahertz. Very important is not just the scrolling issue. Yeah, it has performance 1.25 dBs. It means about 90 dBs maybe. Yeah, that's why I speak the 5 times faster than Artemis 1. Yeah, and similar about 500 flash memory, and there are so many peripherals in here. Not only USB ART or timers, SPI, USB cam, and so on. Yes, we we are using communication system on TTL and RS-485. We are using before about 40 RS-485. We have changes RS-485 to TTL system now. I'm going to explain the other devices, especially for actuator RS-20AM. The RS-20AM is very different from the old RS-28, especially for this point, potentiometers. Yeah, we have changed the potentiometers from some contact type, register type potentiometer to contactless type magnetic potentiometers. And that means you don't have to worry about some kinds of problem from potentiometers, because every time the problem occurs, the contact point, there may be the Robotis like this, but you cannot see the new DARwIN version because they are using contactless potentiometer. The second point for magnetic potentiometer is that we are not using anymore some kinds of AD converters. We are directly digitally connect to this magnetic potentiometer by SPI communication. That means you don't worry about the some like signal noise. Yeah, there's the point of this RS-20AM. Because we are using a more faster CPU in the RS-28 also, the communication time is 4 times faster than old one. Yeah, next is sensors. We are using 4 kinds of sensors. Actually, a gyroscope is 3 axis. Yeah, we are using 2 axis maybe before. We are now extended 2 axis to 3 axis. And accelerometers and 4 FS sensors in each field with totally 8 FS sensors. And we are using, as you know, USB camera. Normal USB camera, but it has some very high definition cameras from Logitech maybe. You can find some information from the website or something at Logitech C945.
Some of them are not standard. Some of them are optional, right? This is so. For example, the force.
Yeah. That's right. You're preparing for first sensors for option. Yeah, you're right. You mean that? This one? Yeah, that's right. Yeah, because we are using some kinds of different potentiometers with resolution. Also, we maybe sometimes accuracy. Yeah.
And it's not using the RS-485.
Yeah, that's right. Yeah.
So that's the difference between for those dynamic silver motor users. That's the big difference.
Yeah. And some sound systems, speakers, and mic. We are using 3 mic. One mic is basically from USB, and the other, these 2 mic is directly connected to 730 for detection, some kinds of unique direction. As you know, from sound detection. Yeah. And second, we have so many LEDs here. For example, like this point and this point has a 16-bit full color LED system, and over there, there's board 6 one color LED. Maybe you can program by our API. And there are several push buttons for interface. You can program it by API too. And we provide SAPS and battery. The default battery is almost 1 ampere. It's operating DARwIN-OP about 25 minutes. But we can we're preparing some kinds of optional battery for large capacity, about almost 2 ampere. You can operate the DARwIN-OP by large batteries for about 40 minutes or 45 minutes maybe. Okay, next is software specification. As I mentioned before, we are using Linux Ubuntu system. There's the package version and kernel version exist. Yes, we provide some framework called Open DARwIN SDK. It compressed by C++. We are using compiler by general compiler GCC, and we are adapting scripts for iterative development environment. Yeah. You can use any kind of environment because we are using the normal PC system. Yeah, just is our recommendation.
So this is what the company Robotis is going to be shipping DARwIN-OP with. However, as you will see later, you don't have to use that. You can run Windows if you want. You can erase all the software and have your own.
Yeah,
this
that's
is what Robotis is going to be actually
that's
supporting. Technical support is based on this stuff.
Actually, I talk about later this detailed information later, but I would like to say about that we are using some version for control system, so-called control system, and for remote desktop VNC or FreeLNS, as you know, yes, we are using a cookie for, as you know, SS terminal client. Yeah. We already installed Samba to DARwIN-OP. You can connect easily by Mac or by Windows, by connecting network, right? And especially we are going to supply some kinds of software tools. There are 4 kinds of software tools. For example, about motion and working and device management and vision monitoring. I'll talk about later more detailed information. Okay, now it's time to exercise yourself. Him and I help you some kinds of setting up. Before setting up the network, you must turn on the DARwIN-OP. Okay. There are some kinds of AC code in front of your desk. Are you ready? It's time to meet DARwIN. I'm
Yes.
You can provide a power by batteries, but we have a lot of time. You better connect by a SMPS, right? As you can see, there is some AC jack over here. Using this one, please plug in this point.
Plug in the power. The back.
Are you ready? Next time, you must switch on. This power switch you just here. You see this? Okay. And press right side. Are you ready?
To turn it on.
Just turn it on to the right.
Oh, the power button. You got it.
Oh.
You break it, you buy it.
Yeah, that's the point.
This is the reset.
Okay, everybody okay? Everybody turns on the DARwIN-OP?
Yeah, that one. But don't worry.
Okay. Okay, now, maybe DARwIN-OP takes time over 1 minute to bring up. So you must be ready. During the time, I would like to suggest setting your network. I already set up the network for DARwIN-OP like this. All thing you need to do is like this. Before that, please connect the LAN cable. Okay. Of course, there's a wireless system with DARwIN, but I would like to recommend you using some wired network for developing. Because of stable connection state. Yeah. Actually, I already installed the DHCP DARwIN-OP, but I would like to recommend this system.
If you're having difficulty, just raise your hand. We'll get help out.
Anybody has problems? That's okay? In case of using Windows, please look for this information.
책임님, 그 친구를 앞에 앉으면
That's okay. 101 or 100, that's okay. No problem.
해보실 수 있으니까.
Important issue is gateway and network. Oh. Are you going to
Yeah, we're sharing. This guy? Right. I just have discussed
Main users. Where is main users?
Because you just in case
Window users.
tip over.
Okay.
It's pretty robust. You don't want to use like I did it as a robot.
If you connect correctly, you can beat dying now. Not now.